All right, welcome everybody. My name is Lindsay Rickershauser, and I am the product manager for ChemDraw at Revity Signals. Thank you everyone for joining us today. I am going to be talking a little bit about creating visually stunning graphical abstracts to really help your chemistry and your research stand out. So today, most of what I will be talking about is really around how you can maximize all of the features and functions within ChemDraw itself to really help yourself more efficiently create those wonderful abstracts and make them stand out. So let me go ahead and quickly move to the next slide and show you some of the things we're going to talk about today. So today, of course, the spotlight is on high impact abstracts. So how do we make those abstracts stand out? Of course, today my focus is on the chemistry, less on the actual text that you might put together for an abstract. So what we're going to talk about today are things in the categories of maximizing your drawing settings within ChemDraw, how to get to settings that allow you to very quickly and easily communicate your chemistry very well, adding in things such as color and 3D, and maximizing the use of things such as templates or stationery and style sheets within the application itself. Okay, so today we're going to talk, I've pulled some abstracts out of some of the recent journal publications that I have been looking through in the last month or two, just as really nice illustrative examples of things that you can draw and things that we can do to make some of these look a little bit higher impact. One thing I want to emphasize is none of the things that I pulled out of the literature today have anything wrong with them at all. All that I wanted to do is have really a basis of some reactions and some schemes to work off of so that I can help you guys in your pursuit of creating this high impact chemistry. So example one is a publication that came out of Organic Letters. Example two here on the screen is a nice little natural product synthesis, came out of Angevante. And what we're going to be focusing on, like I said, is how to set up your drawing settings to make it much easier to get your preferences exactly correct. Maybe it's your own drawing preferences, maybe it's the preferences and requirements for the journal publication that you are submitting for, and how to get all of that set up so that you don't have to mess with it. You can simply open a new template or style sheet to get exactly what you want and begin drawing. And then how to add some strategic highlights and colors to really make that chemistry pop and highlight the most important aspects of the chemistry that you're doing in your research and your work and that you're publishing on. So without further ado, I'm going to go ahead and jump right into ChemDraw. So I have this abstract that I have pulled out of Organic Letters. It's a really nice abstract. It is some concise chemistry. We have a nice reaction here where we have two components coming together in a cyclization reaction, and we're using a really nice ligand. So nothing about this is wrong. Like I said, I am really only focusing on this as a way to illustrate some of the things and features that are available inside of ChemDraw. So I've gone ahead and I've drawn this, oops, excuse me, I already have a tool actually selected. So I've gone ahead and drawn this scheme in my ACS 1996 style format. If you are interested in understanding what styles are available to use to start out with when you are drawing, from the file menu in ChemDraw itself, you can create a new drawing from a list of different stationaries, they're called in Mac. If you are using a Windows version of ChemDraw, these are called style sheets. You can see the most recent one that I've opened is ACS 1996. However, I have a lot of different other options for myself. So if you are submitting to any of the other journals that are in this list, you can of course start there. I actually start myself from ACS 1996, and then I start to actually make modifications to make that chemistry pop a little bit better as I get into that. And everything I'm going to show you today hopefully will allow you to create your own document settings and save them into your own stationery. So once we get to a point where we're ready to save this as a stationery, I'll show you how to do that and how to access that. So first things first, as I have come in here and I have drawn this particular scheme, this looks really nice, but what I can see is if I start to zoom out at a level that I might see in a journal publication right next to a block of text, this starts to get a little bit harder to see, right? The line widths of my bonds are quite thin. It's hard a little bit for me to see those hashed wedges. There are, certain things about the bonds that are a little bit too close together, right? When I have this R1 group there, it's actually covering up that bond between my R group and my nitrogen. So there's some things that I want to change about that. So I'm going to zoom back in and I'm going to start looking at some of the things that I can do to change. So in ChemDraw, you have your document settings. So this is a place where you can very much control how the structures will look, a lot of aspects of your drawings right here in the settings menu. So File Document Settings will bring up a new modal dialog. Now in here, you can choose your layout. So my personal preference when I come in to draw in ChemDraw is to use the poster style. But before I do that, I go ahead and I change the dimensions. So I have this set to 22.5 inches by 30 inches, meaning it's really 4 pages by 3 pages. So it's a very large canvas for me to work from. But you can imagine here, if you are working within a specific size constraint, you can actually set your layout to that particular dimension. So where you have a very small area, if you know that area, you can actually set that, and then you know what bounds you have when you're actually drawing that document. Additionally, you can select whether you'd like to see that drawing in landscape or portrait for printing purposes if you need to print it out. Coming into the drawing settings, though, this is kind of the crux of where you can start making some of these changes. You can control quite a few things in ChemDraw itself. So you can control, starting at the top, the angle of the bonds when you are creating long hydrocarbon chains using the chain tool in ChemDraw. You can control the bond spacing between atoms. So what is this? So I'm sorry, I said atoms. I meant bond spacing, so between bonds themselves. You can control the space between double bonds, triple bonds, quadruple bonds using this bond spacing. So right now, the default settings are that the bond spacing is set to 18% of the length of the bond itself, and the fixed length of the bond is 0.2 inches with ACS 1996. You can adjust that if you want. If you want to see double bonds, triple bonds closer together, you can adjust that lower. If you want to see them further apart, you can adjust that higher as well. I'm actually not going to change that right now. What I'm going to focus on are these next few fields. So the fixed length, the bold width, the line width, and the hash spacing. So what are these? So the fixed length is the actual bond length that I'm going to set in ChemDraw. The bold width is the width of a bolded bond. This also controls the width of a hash or wedge bond. The triangle, the end of that triangle, that will control that width. So whatever you set as the bold width, 1.5 times that bold width will be the length of the end of that triangle for a hash or a wedge bond itself. The line width is what matters here for me in a big way. So what I'm actually going to change is this line width. I'm going to move it to 0.022 to create a little bit bolder line widths here. In addition to that, I want to create a little bit more length in my actual bonds themselves so that I can see all of those bonds in question. I'm going to leave my bulb width the same because I like the current shape of those triangles, those hash and wedge bonds themselves. The margin width. So this is a really interesting one. What this does is it controls the margins around any atoms or labels within your structure. And what that does, the larger you set this width, the larger the space around it and the more it would cover up a bond that it is connected to, if it's an atom, for example, or a label. So if you need to adjust this, you absolutely can. I don't typically adjust this. I like the margin width with ACS 96, but if you need to adjust it lower, you absolutely can. And then the hash spacing, this really controls what the length, the actual distance between the hashes when you're using a hash bond. I like this just a little bit smaller from ACS 1996. So I'm going to make these changes here, and I am going to go ahead and press OK. And what that's going to do is it's going to ask me if I want to actually modify my existing scheme or if I just want to use these drawing settings going forward. So what I'm going to do, I'm going to say, yes, I'd like to modify this. So I can see now how that starts to change. Now, as we see, this is actually much more bolded. This is much more easier for me to see in my drawing. And I can now start to see that bond between my R1. Now, if I want to create a longer length here, all I have to do is I have to select my R1 and press my command key, and then I can move this bond anywhere I'd like. So if I want to just make sure that that bond visually can be seen, I can do it that way as well. A few tips and tricks here. A lot of times when you are creating these different connections on your structures, for example, my R1, R2 group, if I'm drawing this, for example, if I come in and draw my second structure here, I'm going to just use some hotkeys, so bear with me as I talk. Oops, I did that wrong, actually. Let's come over here, put my nitrogens on. I'm going to press 1 to add an alkyl bond here, and then I'm going to press R. And that's going to put just an R there. If I want to actually change that to an R1, I can press Enter. And what that's going to do is put me into text mode, and I can press R1. Now, if I simply press R1, that's going to put that into subscript. What I don't necessarily want in this case is subscript. I want superscript. So instead, I'm going to come back. I'm going to delete that one. I'm going to select Command plus. That's going to put me now into superscript mode, and I'm going to press 1. So that's going to quickly get me to my superscripted R, and then I can keep building my structure here. So I'm going to press 1 to add a carbon, 2 to add a carbonyl, 8 to add my double bond, 1 to add another carbon. I'm going to press R again, Enter to get into text mode. I'm going to press Command plus. I'm going to press that 2 again. So quick and easy tip to get those superscripts if you prefer those superscripts as opposed to those subscripts when you're drawing those R groups and attachments. Another nice little quick tip here is if you want to get your chemical formulas into chemical formula mode, if you select that and you press Command F, that's going to automatically change your molecular formula to the correct super and subscripts as it is written, which allows you to go ahead and type easily on that keyboard and then go ahead and create that molecular formula. Okay, so now as I'm getting into here, so I really like these bond widths. I like the boldness. The next thing I'm going to think about doing here is I'm going to think about how I might add some color to give my audience a more clear sort of view into the chemistry that I'm doing. So what I can see here is, first of all, I have two fragments coming together in a cyclization reaction. I might want to do a few things here. So first of all, I have 27 examples of this synthesis that I have done. So how do I want to portray that, right? So the first option is really to highlight all of the points of variation on my molecule itself. So if I look at all of these different R groups, I might want to add some color, right? So I have this arrow group, I have a variation of an R group here, I have a variation here and here. I have 4 variations to pick from. So what I'm going to do, I'm going to bring up my different color and highlight menus. So if you want to apply ring fills, you have a ring fill color toolbar that's under the color option of the menu, and the ring fill color toolbar. Additionally, you can add highlights as well. I'm going to start with highlights because that's really what I first want to do is start highlighting my variations. So I'm going to select my 2 arrow groups and I'm going to create a highlight. So now I can see on my molecule where that first point of variation is. I'm going to select my R's and I'm going to select a different color and I'm going to go through and continue with my selections here to get a nice set of variations in my colors. So now I actually have a really nice illustration of all of the points of variation in this molecule. I've been able to synthesize 27 examples, variations at all of the points that are highlighted on the molecule. This starts to give my audience, as I'm reading this abstract, as I'm looking and passing through, the points of variation in the interest of the series that I've actually synthesized. I can take this a step further. So I have this catalyst, or this ligand rather, that I've used. So I can actually highlight this for purposes. I actually am not going to use a highlight or ring fill in this case. What I'm actually going to do is I'm going to use the other colors that are available to me. I'm going to create this in a blue color to kind of highlight. This is the actual ligand that I use. I'm actually going to make this a little bit smaller so it fits really nicely under my reaction arrow. And now I'm starting to see some really nice distinction here, right? So it's starting to look a little bit more visually interesting than no color and just. So the last thing that I might do here, and the one thing that I didn't show you in the document settings, is to bold everything, all of the atom labels, right? So you might want everything just to look a little bit crisper. And so adding the bold to those atom labels is another way that I can do that. Now, if I open up my document settings again, I can take a look at where some of these other things exist. Let me move this highlight and ring fill toolbars over. So I have the ability also, in addition to controlling my drawing settings, I can also control my text and my atom labels. So if I look at my text, I can actually select the sizing and the font that's available to me. And for any text boxes that I put on the canvas, I can select whether I want the alignment to be left, centered, right, or justified, in addition to the font style. So I just, for my specific reaction, highlighted and bolded all of those atom labels. But if I want my text also to be bolded, I can set that here. And now I can come into my atom labels and do the same thing. So I have my font style, I can bold it I'm automatically in molecular formula mode, which allows me in the atom labels to get to those subscripts rather easily. Okay, now I'm going to press OK. And this is going to now modify all of my atom and text captions to be bold in this particular document. So I'm going to say modify existing. Okay, wonderful. So now I'm starting to see something quite nice and high impact. And for some reason, my plus and my minus have kind of shifted. Okay, so one other thing that I might bring up here is as I'm drawing these things, this is likely a catalyst that I've used often. I might have to draw quite often. And one thing that you can do in ChemDraw is to draw these and save them as templates. So if I come to my view templates, I can pull up Lindsay's template. So I've created a new templates document that allows me to see my templates. So this particular molecule, I've actually saved it here already. So if I want to select it, I can go ahead and select that. I can put it on the canvas and look, I already have that. I don't have to redraw it. It's actually already in the style that we are actually putting together right now. So I can get it on the canvas rather quickly. If I want to add to these templates, I can go to my file, open templates, and go to Lindsay's templates. And now I can come in here and actually add to it. So maybe I actually used several different ligands that were very similar. So I can come in here and I can add more to this. So maybe I had a few pendant methyl groups off of this catalyst and I wanted to save this. I can go ahead, file, save, and now I have this available to me to actually use. Now I can open each one of these templates if I'd like, or I can open it from the tool on my toolbar in ChemDraw itself. So I have Lindsay's templates available here. If I wanted to select that and draw that, now I can use that in my chemistry. So this is quite easy. Once you actually draw a scaffold, you can save it for future use. So you don't have to redraw it from scratch. You don't have to copy and paste it from an old document. You can get that quite easily and quite quickly within ChemDraw itself. So where were we? So the next thing that I want to show you is maybe a little bit different way that we can highlight this specific reaction. So maybe instead of showing my points of variation, I want to actually show the different disconnections in my molecule, in my final product. Somehow I'm in 3D mode. Okay, so I'm going to go ahead and clone this so I don't have to draw it again. I'm going to go ahead and select my reaction. I'm going to press Option. And that's going to give me a little hand, I don't know if you can see it on my screen, that has a plus inside of it. So what that means is I'm going to clone this. I'm going to drag it right underneath and place it exactly where I want to. Now that I've done that, I'm going to go ahead and just remove my highlights so I can start anew here. And what I would like to now do instead is apply some highlight coloring to the different fragments of my molecules that have been put together in this process for my reaction, right? So I'm going to take and I'm going to do a quick highlight and ring fill of my first reactant here. And I think what I'm going to do here is I'm going to do a ring fill and highlight. Now what I don't have is the exact same color here in my toolbar for highlight. So what I'm going to do is I'm going to go and I'm going to grab that color. I'm going to press OK. And now I have a really nice highlight. And actually I'm going to just zoom in so we can see a little bit better what's going on the screen. Okay, so I've got a nice pale green now for my reactant 1, and I'm going to do a little bit bolder green for ChemDraw for my reactant 2. So I'm going to go ahead and grab that same color. And now I have a nice bolded green for reactant 2. What I can do then is do the same thing on my product. So now I can easily map my reactants and my products. Let's see. I go ahead and grab that, press OK. And now I'm going to grab the other fragment as well. And I'll see very clearly where my fragments are coming from in my molecule. And if I'm looking at it this way, I actually start to think maybe I should be reorienting the starting materials to more accurately reflect the orientation of the product, right? So perhaps instead of having this imidazole in this orientation, I can start to move that in a little bit different orientation. So I can start to show and build my molecule. So I start to, let's see, let's get this guy straight up and down. I start to show my audience exactly how I'm connecting my two fragments up. And now that I've changed this, let me see, I'm going to move this a little bit out of the way. Whoops. And I'm going to do a reaction cleanup. Let's see if we can do this. So if I press Command Shift X, that's going to do a reaction cleanup. So what that's actually doing for me now is that's aligning all of my cores to the center of the reaction arrow and moving everything sort of in alignment. So if you want a quick and easy way to do that, the shortcut key on a Mac is Command Shift X for the reaction cleanup itself. That also, if you don't have this plus and you want it in your reaction, if you haven't drawn that as part of your reaction, when you double click the arrow and do that reaction cleanup itself, that your reaction cleanup will add your plus between your reactants. So that's a really nice, quick and easy feature. The other thing that I will say here, so as I've done this highlight, so the distance between the bonds here makes a little bit of a difference, right? So I have this highlighting on this double bond. What I don't really love is that I kind of have my double bond outside of that highlight. So what I can do is I can open up my object settings and I can change this to a little bit smaller to bring that double bond inside my highlight itself. So I modify my existing, that's going to start to bring that in. And actually, that didn't do exactly what I expected. Let's see, 3. Let's modify, there we go. So we start to see closer double bonds, and now we're fully inside that highlight. So if you'd like to do that, you absolutely can. I'm going to back that out. I like the highlights a little bit bigger there. And now let me just zoom out because we're 400%. So now we've got a few different options. Now, of course, the colors and the highlights that I'm applying here are my personal preferences. There are plenty of different colors to choose from. If there are others that are higher impact or more visually appealing to you, I highly recommend that you play with this and you find some color combinations that really work for you. Also, very willing to hear if there are colors that are missing from these lists that you would like to see as part of the different palettes that are available to you. So just keep that in mind. We love to have feedback from our end users out using ChemDraw every day in the trenches, so definitely would love to hear from you about that. Okay, so now that I've gone through one example, we're already 30 minutes in, I can't believe it. I'd like to move on to a different example, but before I do, I just want to kind of zoom out and show the different variations here, right? So variation 1 pretty clearly looked like it was very close, if not drawn in ACS 96, very, very close to that. So what we were able to do through the document settings was to create a little bit bolder, more higher impact scheme itself, just by adjusting those bond widths, the bond lengths, and the hash spacing. I was able to show you as well how to save some templates so that anything quite complicated in terms of a scaffold that you're drawing, you can quickly and easily save that and access it again in the future without opening up and finding where you drew that molecule. And then I showed you as well how to apply strategic colors and highlights and ring fills to start to bring attention to the pieces and parts of your reactions and schemes that matter, that you're really trying to showcase as part of your chemistry. The one thing that I'll say before we move forward is that all of this, once you get in terms of your drawing settings, settings that you really like, things that really work for you in terms of bond lengths and bolds and all of that, the best thing to do so that you don't have to change this on a fairly regular basis is to save your own style sheet or stationery. So how can we do that? My best suggestion is to open up a new drawing and to set up all of the documents and preferences that you'd like, settings and preferences. So if I come in here, I'm going to change this to a poster because I don't really like to see the line variations for the different pages. I'm going to just set this to a really healthy width and height so that I don't have to worry about going outside of my document lines as I go through and draw my different schemes and reactions. Typically, when I'm creating a ChemDraw drawing, I'm not just drawing one reaction, I'm drawing lots of them all together in one space. So it's kind of my scratch pad. I like to have things really nice and large. The other thing here, I'm going to come through and change some of these settings for myself so that I don't have to do that again in the future. So what am I going to do? I'm going to set the line width here to 0.022. I'm going to leave my bold width and I'm going to create just a little bit smaller distance between my hashes themselves. And I'm going to then go through and ask for my atom labels to be bolded. And now I'm going to go ahead and press OK. Now that I've created this is still an untitled document. I can save this specifically as stationery. So what I'm going to do is save this as my ChemDraw Connect abstracts stationery, and I'm going to press save. So now this is a stationery that I can use. So if I open this up, I can now find and use regularly my ChemDraw abstracts, ChemDraw Connect abstracts, style sheet, or stationery. If I want to make this my default new document, I can come into my preferences and I can open up my preferences and I can get to my open and save preferences and set my default stationery pads or style sheet on Windows. So if I go through and I browse, I can say, I want this to be my default stationery. So every time a new drawing opens in ChemDraw, it is going to use my ChemDraw Connect abstracts. The last thing that I would say is if you want always that same style sheet to open, you might want to also unselect this new from any stationery pad changes default. So what that setting does is the last stationery that you used will become the next stationery that default opens for you. So if you don't want that to happen, you want that sort of free reign to open any of the style sheets that you want, but not for it to change your default one that opens, you can set that here. The last few things that I would show you in the preferences as well is you can set up some preferences for how you view aromatic displays. So whether you like to see the alternating double and single bonds inside of a benzene ring, or if you would rather see the aromatic circles, that comes down to a personal preference thing. And then you can also choose what your default tool is. If you want it to be the last one you used when you last used ChemDraw, you can set it to that. That is the default. But you can also have it set to your solid bond. So if you're always coming in and you want to draw, you don't want to select, you can do that. Otherwise, you can also select a lasso or marquee tool, or whatever was last used in ChemDraw when the last time you saved and closed a document. Okay, so I'm going to apply this so that now my default is ChemDraw Connect Abstract, which is really nice. Okay, I'm not going to save my unsaved document because that no longer matters now that I have my stationery. Okay, so I'm now going to come in to example 2. So this is a nice synthesis coming from Angevante. So I don't have a lot of time to show you kind of tips and tricks for drawing today. The one thing that I will say is that hotkeys and shortcuts are really, really fabulous in helping you to draw these schemes very quickly and easily. If you ever want to understand what kinds of things are available, in terms of using your keyboard to actually draw these schemes instead of point and click from the toolbar in ChemDraw, you can always pull up the hotkeys and shortcut cheat sheets. These will give you quick, easy shortcuts and hotkeys that let you start to draw things on the canvas really quickly. The other thing that I might highlight as part of this as well is when you're drawing, so if I were to pick this molecule to draw and I would start drawing my, my silicon methyl groups here and any terminal sort of methyl groups, if I want to see that on the canvas, the default document settings and preferences are such that you wouldn't see the methyl group, the CH2, CH3s as part of that. But if you want any of those terminal groups to actually show those, there is a setting for that as well. Let's see, if I go through and I select this on the canvas, I can open up my document settings, and in the atom labels, actually coincidentally we are there, I can select to show labels on terminal carbons. And that is in, like I said, the document settings. So if you want this to be default for yourself, you can absolutely do that. So that's really nice. So now I all of my terminal methylene and CH groups by default. So I don't have to do anything to achieve that. You can also, so if I were to just change this to a C, what I'm going to get is a CH3. If you would rather that be a methyl instead of CH3, you can use the keyboard shortcut for M if you are over top of any of those carbons to get to that methyl group as well. Okay, so let's take a look at how we might build this specific molecule. So I wanted to take a really quick one more illustration of how changing these bond lengths and widths really can make an impact. So what I'm going to do is I'm going to change the object settings for this specific structure, and we'll see how they kind of compare. So I'll do a little bit of an in-between compared to the previous abstract that we were looking at. So if I pull this over here, and I set my line widths to 0.15, so a little bit kind of in between ACS 96 and my previous settings. And then I'm going to change the hash spacing a little bit here too. And I'm going to give myself some bolded fonts. So this is now a little bit improved, a little bit more bold, a little bit higher impact version of my scheme, right? And actually, if I look at this scheme, it's actually looking a little bit closer to what was actually drawn in the abstract itself, right? Now I'm going to take that one step further, and I am going to make it all just a little bit more bold so we can see exactly what Lindsay's preference is today. Okay, so now I'm going to change this to 2:1. I'm going to also change my bond lengths to be just a tad hashed, a tad longer, and I'm going to, let's leave this pretty much the same as the previous. I still have my text labels bolded. I have my font bolded for my atom labels, and I'm going to go ahead and press OK. I'm not going to modify existing so that I can still see kind of this difference between the iterations. So now this is really starting to be much higher contrast. I can see everything that I need to see as part of this molecule. I've got my terminal carbons labeled. So this is starting to look really nice. Now, one thing that the authors did in their abstract is they highlighted the bonds that they were creating as part of this reaction series. So I will start to now play with highlights and ring fills to get that nice sort of coloring that the author was trying to convey when they did that. Now, what they did use was colors for the actual bonds themselves, and you absolutely can do that. The only thing that I would say as part of that is it for my preferences doesn't bring enough attention to the bonds of interest that I want my users to know when they're looking at this abstract. So I'm going to instead apply highlights and ring fills. So what I can do here is I'm going to highlight the 3 bonds that are created as part of this reaction, and I'm going to highlight them at nice green. And now I'm going to, in the products, do the same thing. So I'm going to highlight these 3 bonds. I'm going to go ahead and select them. I'm going to select them here as well. And I'm going to highlight them a nice green. For me, that's not quite enough. What I actually also want to do is kind of highlight that core central cyclohexene itself. So what I'm going to do as well is I'm also going to apply some ring fill color. So now I have a really nice quick view of what's being created. The last thing that I would do is to highlight the actual centers of interest that are creating these bonds on the starting material. So what am I going to do? I'm going to select all of the components that are contributing to this cyclization reaction, and I'm going to do the same green highlight to show where those bonds are being created from. And so now I have a really nice sort of visual indication of how I'm mapping the starting material through to the intermediates and through this divergent synthesis to the final products themselves. If I want to align all of these, maybe these aren't quite as aligned as we would like them to be, I can do an alignment here using my object settings. So if I select, this is my object menu. So if I go to the view and select show object toolbar, you're going to get a list of a toolbar that allows you to use different object settings themselves. And I can ask this to align the top, bottom, and center. And whoops, I selected all of my text too, which I did not want to do. I just want to focus on my core. molecules, and there we go. We were just slightly off center there. Now this allows us to follow directly through to the centers of my structure. So now that I have that, the last thing that I will show you, I'm going to just clone this one more time, is different fonts that you can use. So in ChemDraw, you can use the standard fonts that are, applied in any of the document style sheets or stationaries that you may use, but you also have quite a few other fonts to choose from. In my instance, I would like to change this font. So I'm going to change it in both the text and the atom labels. So I'm going to change it, to Honk and Grotesque, which is this font style that's actually in my PowerPoint presentation. So I'm going to go ahead and make sure that I have this. Oh, I don't have that bold. Let's select the bold one, and I'm going to select also my Honk and Grotesque for my atom labels, also bold. I'm going to press OK. And I'm not going to modify existing. I just want to modify this for this specific reaction. Oops, I did that through the document settings instead of the object settings. So that we can see the difference here. Let's get that there, and don't modify existing. There we go. Okay, so now you can see we have a little bit different font style, but now this fits in really well with my PowerPoint slide. So I'm able to make my chemistry now fit in with the font styles that I'm using. So if you have custom fonts that you're using, they're installed on your machine, on a Mac, you'll be able to access those through ChemDraw. And so you'll be able to match those font styles for atom and text captions within any of your presentations or abstract that you're putting together. Okay, so now that I've gone through a second example, the last thing I wanted to talk through, and I don't have a whole lot of time, so I'm going to really focus on the aspect of being able to use 3D in your graphics. So in ChemDraw itself, you have a built-in functionality that allows you to get to 3D orientations of your molecules. It's called 3D Clean. So when you draw something 2D on the canvas, you're able to access the 3D rendering of it through your structure toolbar or through hotkeys and shortcuts. So I'm going to quickly show you how you might draw this as from an to put into your abstract. So I've got this cat name example itself. I'm going to try to go through this rather quickly, so please forgive me if I get any parts of this structure wrong. So I have a cat name that has 1, 2, 3, 4, 5, 6, 7, 8, 9 benzenes and or pyridines as part of it. So what I'm going to do is I'm going to first draw my benzene. And now let's just zoom in just a little bit. I'm going to use some hotkeys to draw. So I'm on the edge of my benzene on this carbon that's pointing to the right on the canvas, and you can see my hot spot keeps moving as I use my arrows. If you notice on my screen, I have pop-ups coming up on the screen showing you what keys I'm actually pressing. So what I'm going to do is press 1, then, didn't want that, A, 1, A, 1, A, until I get to 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I don't have to press 1 and then A. I actually can just press 1, or I'm sorry, A, as I'm doing that to build the linked benzenes. Let's see, I just want one more alkyl. Now that I have that, I can actually connect these. So I'm going to just create my pyridines here, and I'm going to select this carbon, and I'm going to connect it to the other end of the benzene. And right now what you're seeing is, man, this is a 2D item that is really meant to be in 3D, right? So what I can do is select control, or I'm sorry, Shift Option D. That should do a 3D clean. Let's see, give me my structure toolbar. Where are you, structure toolbar? Oh, he's at the bottom, sorry. Let's see, give me my Control Shift D, still not doing it. I must have something that's co-opting my 3D clean today. Sorry about that. And now I have this really nice circular product. Okay, so now that I have this, let's get this kind of rotated to the beginning here. I can do lots of things with this, right? So I can create ring fill colors. I can start rotating this back and forth. I can create different orientations. What I am also going to do now is create the other one, and we'll see how that works. So I'm going to go ahead and build my second one, and let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's get those together. 3, 4, 5, 6, 7, 8, 9. And then we're going to create our triazole ring here. I'm going to do nitrogen, 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 and our double bond. And here we go. So now we're going to do the same thing. All right, so I'm going to select that carbon. I'm going to create that link. And now I'm going to select it, do my 3D clean. And now I can, let's do one more 3D clean of that guy. I can see my 3D structure. Okay, so these are a little bit different sizes right now, so I'm going to make this guy just a little bit bigger. Boom, okay. And now I'm going to apply some ring fill colors. So give me some blue colors here. And there we go. Let's see, did we get those everywhere? Oops. Let's start rotating. Lovely. Okay, so now we've got blue, and let's get ourselves a little bit more color on the other one. So, oops. So if you select too much of your ring, if you select the interior ring, you'll also get ring fill in the middle of your ring, which we don't really want because that starts to, instead of create clarity, that starts to remove clarity in that graphical representation. Okay, so now let's see, we're going to kind of even level this out. And what I'm going to do here is I'm going to kind of move this over, right? So I'm going to try to create my concatenate. I'm going to move it in between. And I will start to rotate these together and see how they are moving. So I'm going to just move them a little bit more off center from each other so that now when I do a 3D rotation, I've got these still a little bit off here. Let's pull this guy forward. There we go. And one more. There we go. So now we kind of have these intertwined the way that we want with for the catenanes. Now, if you want to do a 3D clean with these connected, I don't have time. We have 5 minutes left today. The last thing I would say is you can create a floppy bond that goes between both of these to continue to do that cleanup action, right? So let's just do a few carbons here. I'm going to create it. It's going to be extra floppy. Whoops. And then let's connect. And now when we select it, that's now taking both of these cycles into account. And I can do 3D clean, and it will start to make these look a little bit better in terms of their connection. So you can use this then in your graphic representations in your abstract. So once you get the orientation that you like, then you can just, oops, go ahead and delete, and you'll have something that you can very easily and quickly put into your presentation. Okay, so with that, I just want to flip right back into my PowerPoint really quick with some final thoughts. So today, of course, I showed you all the things that you can do. There are many more even in ChemDraw to start to maximize the impact of your drawings, and just final thoughts in terms of how to create those really high impact abstracts. Keep it simple and focused, right? You don't distract from your main message of the research and innovations that you are presenting and putting forward in your research publications. Secondly, ensure your graphics are super easily parsed by your readers. So make sure everything is easily readable, crisp, and structured so that you can get your main point across without any distraction. And then finally, as you are putting new chemistry forward, it's important to highlight the most impactful parts of that chemistry. So emphasizing your specific atoms, bonds, or fragments, using tools such as highlights or ring fills or 3D to illustrate those critical aspects of your work. With that, I will go ahead and open it up and see if there are any questions. And thank you everybody for your time today.
This is great. Thank you, Lindsay. We do have a few questions that came in throughout the webinar. So the first one is, can I make changes in the document settings permanent so I don't need to modify things like line width every time?
Absolutely. So at the end of the first example, one of the things that I showed was the ability to create your own stationery. So the way that you want to do that is to absolutely create your own stationery. So like we did, we just created the ChemDraw Connect abstracts. So once you find those settings that you really like in terms of the bond lengths and widths, note those and then create a new blank document and save it as your stationery so that you can access it really quickly. So we made those changes in the ChemDraw Connect abstracts stationery in my documents. So if I start to draw here, I will see, let's increase that zoom, I will see the settings that I've now set for myself in there. Thank you so much for that question.
Perfect, thank you. The next question we have, is it possible to use the color picker on the windows?
Yes, you will have, I believe that there is a color picker the same way, so you will still have a custom color option. Without opening it on a Windows machine right now, I wouldn't be able to say exactly what it would look like. The custom color is this button right here on the Mac toolbar itself. but you should be able to find it in your color toolbar from the color menu on Windows as well.
Perfect, thank you. How do I find ring fill menu?
The ring fill menu is under the colors menu. So both highlights and ring fills are here. You'll be able to turn those toolbars on using that. So just go to on your ChemDraw menus, you have the color menu, and you can select to show highlights or select ring fill colors as well. Either or.
Thank you. Next question is, how do I change values in my settings from inches to centimeters?
From inches to centimeters, great question. Okay, so in your document settings, you actually have different ways that you can set your drawing displays, right? So actually, I have a display unit option at the bottom. So I am by default looking in inches, and I've familiarized myself with inches, but if you want to look at centimeters, you absolutely can. It will do that conversion for you so that you're working with the right numbers. You can also use points or pikas.
Perfect, thank you. Do we have time for a couple more questions?
Let's see. We can do a few more if you'd like. I can stay a few more minutes.
Perfect. Is within MacBook, if you do Control-C and paste on a PowerPoint, it pastes as a picture, which makes it harder if you want to make modifications as opposed to Windows. Any tips on that, and if there's a way to avoid this issue?
Yeah, that's a really good question, and something that we get a lot. So when you do a Control-C, Control-V into a PowerPoint, it is it's a rich PDF is what gets actually pasted into your PowerPoint, right? And so it's actually then readable if you copy and paste it out into ChemDraw again. So this image, if I copy it and I paste it back into ChemDraw itself, it is not an image, it is actually my structure, right? It's parsed correctly by ChemDraw. I can make those edits and I can paste that then back into PowerPoint. Unfortunately, being able to do an embedded edit the way you can on Windows is just not possible on Mac, and this is more of a constraint of Microsoft products and less of a constraint of ChemDraw. The technology just isn't possible on Mac the same way as it is on Windows to do that embedded edit.
The last question for today, there are more, but we might be running out of time. The last question for today is, where can I select different types of arrows for labeling?
Different types of reaction arrows, I would assume, would be the question. So in general, your arrows are available on the general toolbar in ChemDraw. So you have different arrowhead settings that you can select from. My personal preference is typically using the solid small, but you have all of the options here to choose from. So if you're doing a disconnection and you don't need a reaction arrow, you need a disconnection arrow, you have that. If you're doing a mechanism, you have those arrows available as well. If you need to illustrate equilibrium or a failed reaction, all of those things are available through that reaction drop down on that general toolbar.
Perfect, thank you for this. As I said, we have more questions, but just conscious of time, we might be following up with answers after the session.
Wonderful. Thank you, everybody, for your time. We really, really appreciate it. Thanks for hanging out a few minutes over to get some of your questions asked. We'd love to hear feedback and additional questions. So definitely we'll be in touch to help answer any of the questions we didn't get to today.